All right, for those of you that had trouble either uploading the first video or if you weren't able to understand me, I'm going to do a shorter version here with the notes already filled out. All right, we're starting our probability lesson. Our definition for probability is the chance or likelihood that something will happen. All right, you hear a lot of times probability. What are what are the chances of winning the lottery? What are the chances it's going to rain today? Okay, all that is probability. All right, and the way we set it up like a ratio. However, it can be shown as a decimal or as a percent. But the ratio we're looking to set up is our favorable outcome over the total possible outcome. All right, and the favorable outcome a lot of times is what you find in the actual question. That's what they want you to find. That's our numerator in our ratio. The total possible outcome is how many total sides, how many total objects are we working with. All right, some basic probability examples, such as number one, we're dealing with a quarter. And it says, what is the probability that a quarter will land heads up? So we look at the quarter, and our first thing we need to determine is how many sides does this quarter have? Okay, the quarter has two sides. You'll notice the 2 as the denominator. And then the question is talking about just the heads. All right, and on a quarter, one side is heads, so we place it 1 over 2. All right, the last thing we need to actually ask ourselves is this simplified? And 1 out of 2, or 1 to 2, is simplified. All right, now again, they may show it as a decimal, so 1/2, 1 over 2 is equal to 0.5 or 0.50, which is also equal to 50%. Now, question number 2 says, what is the probability that a fair number cube labeled 1 through 6 will land on an even number? Okay, so we have a fair number cube, 1 through 6, and there's 6 total sides on a cube, so that's our denominator. There are 3 even numbers on a cube, so that's why you see the 3 as a numerator. 3 out of 6, okay, we can divide each of those by 3, as again equal to 1 to 2 is our probability. 1 out of every 2 rolls, I'll land on an even number. Now, with probability, we have 2 types of events. The first event is an independent event, and this is where one outcome does not depend on the outcome of another. Another way you can write it is one outcome does not affect the outcome of another. Okay, and hence the word independent. They're separate from one another. Examples of this are a fair number cube, a spinner. Okay, if you use just a fair number cube and a spinner, if I roll the cube or I spin the spinner, they do not affect one another. The cube's going to land on whatever it lands on. The spinner's going to land on whatever it lands on. Now you take a look at our first example. It says a spinner and a fair number cube are used in a game. The spinner has an equal chance of landing on one of 4 colors, red, purple, blue, or green. The faces of the cube are labeled 1 through 6. All right, so now the first question says, what is the probability of a player spinning the color purple and then rolling a 3? These are independent events because they're separate from one another, and spinning that spinner and then rolling that cube, they do not affect one another. So we'll set up the first ratio, which is our spinner. If we look at, we've got 4 total colors, red, purple, blue, and green. So you'll notice the 4 as the denominator. Now it says spinning the color purple. We only see 1 color purple, so we only have 1 as our numerator, which is our favorable outcome. Now the cube, okay, says, and rolling a 3, well, on a cube we know there's 6 total sides, and on a cube there's only 1 number that is a 3, so 1 out of 6 is our ratio for the second event. All right, now with probability, the operation that we use is multiplication. And when I multiply ratios or multiply fractions, I multiply straight across. 1 times 1 is 1. 4 times 6 is 24. And again, the last thing we need to ask ourselves is this simplified? And 1 to 24 is simplified. So there's a 1 out of 24 chance that we will spin the color purple and roll a number 3 at the same time. All right, now our second type of independent event says, what is the probability of a player spinning the color green and then rolling an odd number? So again, it's independent because these 2, the spinner and the dice, or the cube, do not affect one another. So now, spinning the color green, again, there's 4 colors, so the 4 is our denominator. There's 1 green, so 1 out of 4 is the probability of that. Now, rolling an odd number, again, there's 6 total sides. 3 of them are in odd numbers, 1, 3, and 5, so 3 out of 6 is that probability. Now, multiply straight across. 1 times 3 is 3. 4 times 6 is 24. And again, the last question I need to ask myself is this simplified, 3 to 24? No, it's not. And I can divide each of them by 3. So 3 divided by 3 is 1, 24 divided by 3 is 8, and 1 out of 8 is simplified. All right, and again, make sure you answered the question. Did I get the probability for the color green? Did I get the probability for rolling an odd number? Did I simplify? Those are all the things you need to go back and check when completing your problem. Now, the second type of event, all right, or there's a dependent event. Obviously, if independent, one does not affect the other. Dependent means one outcome is affected by the outcome of another. All right, so on dependent, one outcome is affected by the outcome of another. Now, what we're looking for in these types of problems are examples. We're looking for the words replaced and not replaced. Okay, we're looking for the words replaced and not replaced. For example, if I had a bunch of marbles in a bag, or a bunch of marbles in a bowl or something like that, if I pick one out and then not replace it, the total changes. The total amount of marbles in that bowl changes. However, if I pick a marble out, determine what color it is, and then put it back in the bowl or in the bag, it's then been replaced and the total number does not change. So let's take a look at number 1. Bianca has a bag containing 6 red, 8 blue, 5 green, 9 yellow, and 2 brown M&Ms. What is the probability of randomly choosing a yellow M&M on the first pick, not replacing it, and then randomly choosing a blue M&M on the second pick? All right, so now we can find our key words, not replacing it. Okay, this is going to affect our total number of M&Ms. The first M&M, though, we want is yellow. Okay, the first thing we're going to do is count up the total M&Ms that we have. When I add up 6, 8, 5, 9, and 2, I get a total of 30. Now it says randomly choosing a yellow M&M on the first pick. So I go up to the M&Ms, and it looks like there's 9 yellow, so I place 9 over 30. Now the second probability, okay, we notice a 29 there as a total instead of a 30. It's because we did not replace that M&M. Okay, so the total was changed by 1. So we subtract 1 from that 30, leaves me with 29. The second probability says randomly choosing a blue M&M, and there are 8 blue M&Ms. All right, now with larger numbers, okay, it's going to be easier if you can simplify. 9 over 30, we can divide each the 9 by 3 and the 30 by 3. So if you notice to the side, I wrote the 9 becomes a 3, and the 30 becomes a 10. Okay, now we're going to multiply our ratios, multiply our events. 3 times 8 is 24. 10 times 9 is 290. Now, because the 24 and the 290 both end in even numbers, I can start simplifying. I know that I can simplify by 2. 24 divided by 2 gives me the 12. So you'll notice I just placed the 12 down here. Now 290, okay, is obviously divided by 2. 290 divided by 2 is 145. So 12 over 145. Now, I know that 12 can still be divided by 1, or it could be divided by 2, 3, 4, 6, and 12. I'm not sure what 145 can be divided by. So if you notice, I tried dividing 145 by 3. It doesn't work. I tried dividing 145 by 6. It also does not work. Does not go in there into an even amount of times. So my final probability, my final ratio on this is 12 to 145. Meaning that every 145 times that I try this event here, okay, I randomly choose the yellow and not replace it, and then choose the blue, 12 times, there's a chance that 12 times I will get a yellow and then a blue. Okay, now make sure you've completed these notes for class tomorrow. The 2 problems on the opposite side, this problem and this problem here, make sure those problems are completed for class tomorrow so we can discuss and make any corrections.